There's one more thing we need to talk about regarding parabolas, particularly when we're wanting to graph them, and this helps us to see how wide the parabola is going to be around the focus. If we look at the line segment that goes through the focus and is parallel to the latus rectum and goes between the two sides of the parabola, there is a word for this line segment. It's called the latus rectum, and it has a length equal to the absolute value of 4 times p if we're looking at the equation x squared equals 4py or y squared equals 4px. So if we have an equation in one of these forms, we know it's a parabola with vertex at the origin, and we can figure out what the coordinates are for the focus. And once we've done that, we can look at this length, which has a special name. It's actually called the focal diameter. We know the diameter of a circle is the distance from one end to the other. The focal diameter of a parabola is kind of the distance from one end to the other that goes through the focus. And once we have the focal diameter, we can use that to sketch a nice graph of the parabola. So let's look at one example together right now. Find the focus, directrix, and focal diameter of the parabola y equals 1/2 x squared and sketch its graph. So because we have an x squared here, we know that we want to get this into the form x squared equals 4py. So we know we're going to want to isolate the x squared. And we can do that by multiplying both sides by 2, which will get rid of the 1/2 in front of it. So that'll give us the x squared alone on one side, and then 2y on the other side. Now we want to be able to write this in the form 4 times something times y, so that we can figure out what the coordinates are for the focus. And we know that 2 is 4 times 1/2. So in this case, the value of p is 1/2. So this tells us, of course we know the vertex is going to be 0, 0. But then the focus is going to be at the point 0, 1/2. The directrix is going to be below this. It'll be the line x equals -1/2. And the focal diameter, remember it's the absolute value of 4p, which in this case is going to be the absolute value of 2, which is 2. So let's start drawing this. We know the vertex is at the origin, so we can put a point there. The focus is at the point 0, 1/2, which is right there. And the focal diameter is 2, and what that means is that the width of the parabola at this height is going to be 2, and that means it's going to move 1 unit in each direction, 1 unit to the right and 1 unit to the left, so that it can have a total length of 2. And so our parabola is also going to go through these 2 points. And so that just helps us try and draw it so that the width is accurate. It's not going to be accurate everywhere. We don't know how wide it is up here, but having at least one place where we know how wide it is prevents us from drawing something that's way too skinny. And then if we want to draw the directrix below, we know that it's the line y equals -1/2. That was a mistake. Not x equals -1/2. Y equals -1/2. And so that is this line down here. And so there is our graph. I have one more video for you in this section. I know there's so many videos. This is one of the longer sections, but in the last video, we're going to look at some really interesting reflection properties that are involved with parabolas, which actually explain why satellite dishes work, because those are parabolic. So one last video, but this will be, I think, a little bit more fun and interesting.